Okay, I have a breadboard in which I have some of the circuits connected. Let me just look at positive clipper. Now you can see the diode is connected in the direction shown with this end positive and this end negative. And now you have a transformer here and you have an oscilloscope here. So I switch on. Now the transformer is switched on. I will switch on the oscilloscope. Immediately you can see the positive end has been clipped, and what you get is only the negative excursions of the input sine wave. These are load, this is the series resistor, and this is a diode connected in this direction. The circuit is shown here. The same circuit is implemented here. So RS, which is usually, I have put a resistance here. In general, this could be the internal source resistance of any AC input or the transformer, as the case may be. So now if I want to look at the negative clipper, let me switch off and take the negative clipper. I will reset. Now negative clipper, immediately you see the direction of the diode has been changed, and the circuit is again shown here. The diode again here also is changed in direction. Now I will switch on the transformer. I will switch on the oscilloscope. Immediately you will find the negative half have been clipped, and you get only the positive cycle on the oscilloscope. Both the input and the output are shown here. Okay, both of them are very similar, as I already mentioned to you, to a normal rectifier. Now let me quickly switch off and go to the biased clipper. So let us say a biased positive clipper. Now what is happening? You again have the same circuit with one RS and a diode for a normal positive clipper, but in addition you have got a power supply here, DC power supply. So I am using a voltage source, and the input from the voltage source is connected in series with the diode as in the circuit. And now let us see what happens. I switch on here, oscilloscope, or maybe I should switch on the power supply, and then I switch on the. Now you can see, because the power supply is having 0 volts, it is equivalent to having no bias, and therefore it is the same positive clipper that you had previously. Now let me try to increase the voltage. I applied 2 volts now. Immediately you can see the waveform has moved up little bit by that 2 volts because it is coming in series. That means I must have here a voltage which is larger than this voltage. If this voltage is V, I must have V plus 0.7 to make this diode to conduct, and that is what is shown here. So this is a 2 volts, that is extra volt that is coming here. Actually it is 2.7 volts it will be, because that 0.7 volts will always come in the circuit. So if now I can increase to 4 volts, 6 volts as the case may be, and thereby I will be able to shift this still further if I want. Okay, this is a biased. You can also have a voltage source in the opposite polarity, and correspondingly it will be shifted in the other direction, opposite direction. So this is a positive clipper, biased clipper with a positive bias. Now I will switch off and move on to the negative clipper. So here again I have a diode inverted, and you can also see the voltage source also has inverted as an example. Now I switch on the power supply, the transformer, and the oscilloscope. You can see initially the power supply is 0, and therefore it is nothing but the well known negative clipper. Now if I increase the voltage by about 2 volts, you can see it is depressed by another 2 volts, because it has to increase over and above the 2 volts for this diode to conduct here, and that is the reason why this is coming in this form. So the positive clipper and the negative clipper, and the positive biased clipper and negative biased clipper can be used for different shaping the different sine wave. You can actually combine them too. That is, you can have in parallel one diode connected in the another diode in the opposite direction as a negative clipper, and you can choose the voltages. Thereby you would find you can ultimately convert a sine wave into a square wave if you wish. So by using 2 clippers in parallel, one positive clipper, the other negative clipper, with a bias also, you can have the amplitude of the square wave to any value you want.